Good. So, good afternoon. This is the lecture. I'm not sure if it's B6. I think B6 on discrete data and the multinomial distribution. I don't have a whole lot to say about this lecture. It's basically a similar lecture as what we did for the Gaussian, but now for discrete data. And technically, it's just a simple extension of the example that we gave for the coin toss. Now it is for a die, so a multi-sided coin, if you will. And really, the only thing that changes is the likelihood function or the data generating probability distribution. We used to have a Bernoulli distribution. Now it's called a categorical, but it's still the same formula and or sort of a nice extension of the formula. In particular, if you use this one hot coding scheme for outcomes, then everything is basically the same because you still have in your outcomes only ones and zeros, which you also have in the coin toss. So the formulas look then almost the same. And the prior distribution for the parameters of the coin or the die, we used to have a beta distribution, and a multidimensional beta is called the Dirichlet distribution. Aside from that, it's the same thing. We do Bayesian updating in this class, and yeah, maximum likelihood estimation for the parameters. You can, of course, what we do is we say, okay, let's assume we have we do Bayesian estimation, and then we have a flat prior, so a uniform prior. And then basically I'm doing maximum, I'm taking the maximum of the posterior, which will be the maximum of the likelihood. But that's of course a very roundabout way that in practice, you will just do it by writing down the likelihood function and differentiate. And the thing that you have to take care of, and this is in the last part of the session, is that the sum of the parameters, some of the mu's have to be have to add to 1. So you have to add a Lagrange multiplier. And the best thing, if you haven't seen that before, is to read in Bishop Appendix E. That's a very short session that explains that. Other than that, I think the lecture is short and sort of self-explanatory. So I want to open it up to you and field your questions. Any questions on this class? No questions so far. Is that just me? But I have to say this is the same pattern as last year. The lecture on, or this was considered one of the easier lectures. So I'm not surprised there are no questions. I did notice some of the questions in Piazza. There's a rendering problem with the exercises. I'm well aware of it. I tried to explain in Piazza. It's kind of a pain to solve it because it's a hit or miss thing. If you open up, let's say if you click the link, the notebooks are rendered by NB Viewer, but that's not how it's rendered when I do it locally on my computer. So, and I don't know really what, if you look at the underlying code, it seems to be right. So it's a bit of a hit of a miss thing. So I will keep working on it, but no guarantee I can solve that. Other than that, I've seen some good questions, and I'm going to wait for student answers, and eventually I'll either endorse them or try to make corrections. See, there is one question. Are there problems where we can ignore that the sum of mk of mu k must be 1? Well, yes, there are problems, but I mean, the only reason, let's say, what is the reason? I'm going to put it to the class. What is the reason that the sum of the mu k's must be 1? Anybody has an answer to that?
The total probability is always equal to 1.
Yeah, yeah. So I think that's the right answer, right? I mean, it has to be one of the k outcomes have to come up. It's either if you throw a die, it's going to be either a 1 or a 2 or a 3 or a 4, or right. So the total, I mean, um, the total probability has to be 1. If that condition is not there, so I mean, there will also be sometimes you have problems where your sum of parameters are not going to be 1, right? It's just that in a coin or in a die, we associate. I mean, the problem is structured in this particular way, right? That it just happens to be the sum of these parameters has to be 1. It's just the structure of this problem. Okay. Any other problems? No? Well, very good. Uh, that makes for a short class, which is good, I think. That means that I hope that there could be two reasons, right? It could be that people are understanding it very well, or we're losing people. And I think now is about the right time to do a poll. So I will make a poll in Piazza and ask you where you are in the class. So you may have to throw in sort of a catch-up lecture. Other than that, I don't want to waste your time. So if there are no more questions, and then I am ready to yeah, to stop the class. No more questions. Okay, I'm going to stop the recording. And so next time, by the way, Friday is going to be probabilistic programming again, sort of a recapture of the past 3 classes. And so we'll see you on Friday.